Hello everyone, this is Adish. I'm a grade 10 student from Mumbai. So today's problem is odd GCD. The difficulty level of this problem is simple because you only need to know the concept of greatest common divisor, specifically with one of the numbers in the GCD operation being 2. So basically we are trying to find out the GCD of 2 and x. You only need to know how we can do this in order to understand my solution. So in this problem we are basically given an array consisting of n integers numbered a1 through an, which is basically 1 based indexing. Our goal is to make the GCD of all the elements an odd integer, and to achieve this goal we can perform the following operation any number of times. We can choose any index I going from 1 to n such that ai is greater than 1, and we can set ai to be the value of ai divided by 2, and this function is called the floor function or the greatest integer function, which basically tells you the greatest integer less than or equal to ai divided by 2. And we can do this multiple times for any index, and we need to find out the minimum number of operations after which the GCD of all the elements becomes odd, and that's basically the full question. And the input format is basically the following. We are given an integer t in the first line, which represents the number of test cases. Then we are given t test cases. Each test case contains the first line as an integer n, and the second line consists of the array a. And in the output we just need to print for each test case what is the minimum number of operations after which the GCD of the array becomes odd. And let's take an example. So let's say that the array was 2, 3, 5. Then in this case you can see that the GCD of all the elements is initially odd. It's not even because there are odd elements in the array. 3 and 5 are odd elements. That's why if you consider the power of 2, the power of 2 is 0 in 3 and 0 in 5. That's why the GCD of all the elements is an odd number. So there are 0 operations required. In the second test case, however, 4 and 6 contain at least one power of 2 each. That's why the GCD is initially 2, and basically we can choose the number 6 and divide it by 2 to get 3. Now since 3 is an odd number, the GCD of all the elements becomes odd. And the general pattern which we are seeing is that if there's at least one odd number in the array, and the moment at which there's at least one odd number in the array, at that moment you can stop all the operations, and the minimum number of operations is precisely the number of operations required to make at least one element of the array odd. That's the key observation. And in the third test case you can see that's true, because if you take 4 and divide it by 2 twice, you will get 1, and hence the GCD of all elements becomes 1, which is odd. And if you try to do that with 12 instead of 4, again you can perform 2 operations and get 3, and the GCD of all the elements will become 1, which is odd. So in general, there were 2 operations, 1 operation and 0 operation, so the output is correct. Now in general, let's look at the key observation. So the key observation is that what I just said, there should be at least one odd element in the array for the array to have an odd GCD. And if all the elements in the array are even, then we know that the GCD will be an even number. So that's the key observation which I just told you. Now in order for us to basically find a way to use this key observation, we need to find out the minimum number of operations required to make an element of the array odd. And basically this means that for each element going from 1 to n, each ai going from 1 to n, we will compute this value, the minimum number of operations required to make that element odd, and we'll take, let's say that the minimum number of operations is 1, 2, 1 and 3 and some random numbers. Let's say it's like this. And note that if any of the elements is 0, then we know that the element is already odd. That's why the total answer will be 0. However, if the if the numbers are greater than 0, then the key idea is that the minimum of all these numbers will be the required answer, because the min of all these computed numbers, the min of all min number of ops to make an element of the array odd will be the answer, because we know that if we take any one element and if we perform this min number of ops and make it odd, then we know that the GCD of all the elements will be odd, because we have successfully made one element of the array odd, and hence you will optimally choose the element such that it has the smallest power of 2 and such that the number of operations required to make it odd are minimized, so that the entire array has an odd GCD. And in this way we just need to find out the number of operations required to make an element of the array odd, and as I just mentioned, this is actually equal to the min power of 2 across all the elements in the array. So basically we'll iterate through each element in the array and we will find out the highest power of 2, or we'll find out the power of 2 in the prime factorization of the number, and we will find out what is the minimum power of 2 across all the elements. So let's look at the example again. So in this case the example was 4, 12 and 24. So the reason why this works in this example is we know that 4 is 2 squared, so 2 appears twice, so the min power of 2 is 2, so this is the power of 2 over here. In 12, 2 again appears one time, so again the minimum number of operations required is 2, and in 24 2 appears 3 times, that's the prime factorization of 24, so that's why the min number of operations will be actually 3. So the min of all these powers of 2 will be the min of all powers of 2 is 2, because that's the min power across all the elements, and that's actually there for both 4 and 12. So this means that we just need to choose either 4 or 12 and we need to perform 2 operations on it and we get an odd number, and that's why the GCD of all the elements in the array becomes odd. And in general, if you have some random numbers, if you have like 2 raised to x1 into some number y1, 2 raised to x2 into some number y2, and so on, 2 raised to xn into yn, where x1, x2, x3 all the way up till xn are the powers of 2 in the prime factorization, then the final answer is actually the min of all xi, where I goes from 1 to n, and this basically means that if you take the index corresponding to this min xi and if you keep dividing it by 2 min xi times, then you will get an odd number, and that's why the GCD of all elements becomes odd. So now I just show you the code which implements this idea of repeatedly dividing a number by 2, each number in the array, and basically hence the number of operations required to make it odd after you repeatedly divide it by 2, that will actually be the highest power of 2, and if you take the min across all these powers of 2, you will get the final min answer. So in the C++ code for this problem, first I taken the number of test cases. For each test case you could use a while loop or a for loop. So for each test case going from 1 to t minus 1, we will take in the value of n. Min ops is the final answer, so this is actually the final answer, and it's initialized to some very large number, int max basically, so that you can whenever you perform the minimum operation, the min ops will always decrease. If you initialize it to 0, then the min of 0 with any number will be 0 only, and it will give a wrong answer. So you need to initialize it to a large number, such that when you compute the number of operations you take the min function, you are ensuring that the initial answer is not considered and only the new value of num ops is considered. So in order to compute num ops, you will take in the value of x. You will repeatedly divide x by 2 as long as x is divisible by 2. So as long as 2 divides x, we divide x by 2, and hence we increment num ops, and in the end we know that num ops is the highest power of 2 that divides x, and hence we know that numops is the minimum number of operations required to make x odd, and hence we take the min of this with the final answer, and we keep computing the final answer to be the minimum of the final answer and the new value of numops, and in the end we'll print this final answer, and you can verify that this C++ code gets accepted. And for the Python code for this problem, you can see that some other user has done exactly the same thing. They have actually used a step array, and while the current number is divisible by 2, they increase count by 1, they divide I by 2 using integer division, and they append the value of count to step, and in the end they answer the minimum steps required across all possible values of step, and this gets accepted. So I hope you like this problem and my solution. If you have any doubts, do leave them in the comments down below, and if you like this video, don't forget to give it a thumbs up. Thank you.